In today's lecture, we are going to learn classification of elements by early scientists. So the first one that we are going to learn is the Daubenier's triad. Triads. So Johann Wolfgang Daubenier arranged elements in increasing order of their atomic weights in groups of 3 called triads, in which the atomic weight of the middle element was found to be the average of the atomic weights of the other two. Elements. For example, we take lithium, sodium, potassium. Lithium is 7, sodium is 23 and potassium is 39. So 39 plus 7, that is 46. 46 by 2 is 23. So sodium is the average mean of lithium and potassium. So its limitations. Number 1. Method was a disordered collection of elements not holding true for all elements. This did work for some of the elements, but it was not true for all. Hence, it was discarded. The second one is that properties of elements grouped into triads were found not to be similar. It was not always that the properties were similar. Like in case of lithium, sodium and potassium, all three showed more or less similar properties, but not all such triads showed similar properties. So this was the reason why Drobenius triads was discarded. Next we are going to do is the Newland's law of octaves. John Newland arranged elements in increasing order of atomic weights in series of 8. And the 8 elements after each 7th, that is the 8th element, it showed resemblance in properties. In series of 8 showing resemblance in physical and chemical properties. Between the 8th element and the first element. Which is similar to the 8th and first notes on a musical scale. He was actually inspired by musical notes, like we say in Hindi or in the Indian system of music, sa re ga ma pa da ni sa. So the 8th sa resembles the first sa in the musical notes, and it was actually in his language do re mi fa sol la ti. Then again do re mi fi sa sol la ti would start again, resembling the 8th element and the first element. Now, what were his limitations? The first one, it was found that the law of octaves was applicable only up to calcium and after calcium every 8th element did not possess similar properties to the first. The second limitation, it was assumed by Newland that only 56 elements existed in nature and no more elements would be discovered in the future. The method showed odd grouping the grouping done in the table was not up to the mark and failed to leave spaces for undiscovered elements. As he thought that there would be no more other elements discovered later. And his third limitation, in order to fit elements into his table, Newland adjusted two elements in the same slot but also put some unlike elements under the same note. The reason why is it saying note is because it was compared to the musical notes. So a group basically denotes a note in case of Newland's table. So in his case, what he did was he placed, like, suppose in a group, say there is fluorine, chlorine and bromine. So these are all halogens. With this he placed cobalt and nickel, which was completely different in properties as compared to fluorine, chlorine and bromine. Hence his table was also discarded. The third and a very important table was given by Mendeleev. So Mendeleev basically introduced us the periodic table. The modern periodic table was given by Moseley, but most of the work was done by Mendeleev in that. So Dmitry Ivanovich Mendeleev arranged elements in increasing order of atomic weights in the form of a table called the periodic table. So basically this groups and periods, all this was given by Mendeleev himself. So what he did was, he examined the relationship between the atomic masses of the elements and their physical and chemical properties. So he observed the physical and chemical properties, and among the chemical properties the most importance was given to the reactivity with hydrogen and oxygen. So among chemical properties, Mendeleev concentrated on compounds formed by hydrogen and oxygen, which was treated as the basic properties for an element of an element for its classification. Now, why did he choose hydrogen and oxygen only is because he selected hydrogen and oxygen as they are very reactive and formed compounds with most elements. This is why he selected hydrogen and oxygen. Now, what he did was he arranged. So, on arranging in order of their atomic masses, it was observed that there occurs a periodic recurrence elements with similar physical and chemical properties. On this basis, he introduced the Mendeleev's periodic law, which stated that the physical and chemical properties are periodic functions of their atomic weights. Mendeleev focused on the atomic weight. Daubigny focused on increasing order of the atomic weights. Newland focused on the increasing order of their atomic weights. All of this focused on increasing order of their atomic weights. So, what was his achievements? In some books you might find double F instead of V. That is also correct for his spelling. So Mendeleev's achievements. Number 1. So he could arrange them properly in periods and groups. So elements were arranged in increasing order of their atomic weights in horizontal rows called periods and vertical column called groups. His second achievement was that as he arranged them with respect to their reaction with hydrogen and oxygen, the compounds it formed with hydrogen and oxygen, so elements which are similar with respect to their chemical properties were grouped together and have atomic weights of nearly the same value. Third achievement based on the periodicity of properties a number of gaps were left in the table for undiscovered elements that is elements now discovered. Example: scandium, gallium and germanium, which was originally named Eka boron, Eka aluminium and Eka silicon respectively. The Sanskrit word better numeral, the number Eka meaning 1 was used as a prefix in naming the element, in naming the preceding element in the same group. So Eka aluminium was given because aluminium was preceding the element gallium in the same group. So the fourth achievement, the properties of the undiscovered elements left in the vacant gaps was predicted. So he was able to predict the elements, the properties of the elements left in the vacant gaps, as he saw that the elements which were grouped together had similar chemical properties. Elements which are similar with respect to the chemical properties were grouped together. Hence, he was able to also predict the properties of elements, undiscovered elements in the vacant gaps. He knew that they would be discovered later. Now, coming to his limitations. Number 1, electronic configuration of hydrogen resembles that of alkali metals and on the other hand hydrogen like halogens exists as diatomic molecules. So he could not assign a correct position to hydrogen in his table. The second limitation anomalous pair of elements presence of anomalous pair of elements. Certain pairs of elements have higher atomic weights having higher atomic weights were given positions before the elements having lower atomic weights So this was one of its defects. Though he arranged them according to their increasing atomic weight, still because of having similar properties, some elements with higher weights were given position before the elements having lower weights. To note that this defect disappeared if elements are arranged according to their atomic numbers. Number 3, position of rare earths, that is lanthanides, and actinides could not be justified. His fourth defect, position of isotopes could not be justified and this was resolved on arranging them according to their atomic numbers. Hence, so these are the reasons why we did not accept the periodic table given by Mendeleev as well, but the defects that were here were just nullified or they were removed by arranging them on the basis of their atomic numbers. So from here, the fourth one, that is the modern periodic table or the modern periodic law that we have learned already came into existence. Most of the defects in Mendeleev's periodic table and disappears if the periodic table or if the basis of classification of elements is changed from atomic weights to atomic numbers. So now we know the modern periodic law. We have already learned them. We have learned about 7 horizontal rows called periods and 8 vertical columns called groups. So we have discussed the modern periodic law in detail already. What I'll be going through are some other periodic properties. We have already learned electronegativity in detail. We have learned atomic radii in detail. There are some periodic properties as well, one of which being ionization potential. It is the amount of energy required to remove an electron from the outermost shell of an isolated atom. And the last periodic property we'll deal with is the electron affinity, is the amount of energy released when an atom in the gaseous state accepts an electron to form an anion. With this, we come to the end of the lecture and also the end of the chapter. Please prepare notes and clarify all your doubts.